Welcome in our today's mathematics lesson, and here we are still continuing with the equations, and today I want us to look at application. Earlier on we have seen types of equations, the linear equations and the quadratic equations. It is not enough if we only know how to solve equations. It is necessary that we also know how to apply these equations in our real life situations. If we are able to do that, then we find that we are very well conversant with the equations in our daily lives. The equations are always used in various situations. It can be used in a situation where you are comparing ages. It can be used in a situation where you are comparing the consumptions of fuel and many others. So given a statement question or a statement phrase, we should be able to assign the pronumerals and come up with the equation which will later on be solved, and we find the values for the various variables that we created from a situation. So we find that generally an equation can be used to describe any situation in which two values are equal. A situation can be used to describe any can be used to describe any situation of which two values are equal. And to solve, so I want us to look at the problems we need to follow, the steps we need to follow while solving problems that are applying in equations. So we need to actually follow the following steps. We need to define pronumerals to stand for unknown numbers. When we say this, we can say, for example, let something like T, right, stand for John's age. We have defined T to be the pronumeral for the age of John, which is unknown. So we are saying let T be John's age. So we shall have assigned a pronumeral for the age of John. We also need to write an equation to describe the situation. Now, remember, we are looking at a situation which we may be comparing the ages. When you look at that situation, what equation can we use to represent that situation? If that is done, then we shall have written down the equation to describe a situation, as we are going to see in a little while. The next step we need to do, after identifying and writing an equation, then we need to solve the equation systematically. You write the equation, and then you solve the equation either systematically or by inspection. Now, when you are solving this equation, there are a few important things you need to note. Be sure of the units you are dealing with, so that if you are dealing with, for example, T for John's age, when you find the value of T, you will say this T stands for years. So if T is 10, you write 10 years. If you are solving and you have said X stands for length in centimeters, then when you solve for X, you find maybe X is 3, we shall say X is 3 centimeters. So we are saying that you ensure that you answer the original question, including the units that are going to be used. If it is dollars, if it is years, if it is in measurements, centimeters and meters, you ensure that you use that. So the fifth step, after answering the original question, check that your answer is reasonable and makes sense. You must check that your answer is reasonable and makes sense. So in such situation now, these 5 steps are always going to be applied every time you start applying equations in a real life situation. So I want us to look at problem solving. The situation we are going to come up with, we find out, assign the pronumerals, write down the equation, solve it, and check our answers. That is the approach we are going to give by looking at all those steps I've listed above. So we shall consider those steps as we go about solving these equations. So we've been asked the weight of 6 identical books is 1.2 kilograms. What is the weight of one book? What is the weight of one book? So to solve this, we require that we assign a pronumeral for the unknown. And what is unknown here? The unknown here is the weight of one book. We know the weight of all the 6 identical books, but we do not know the weight of one book. So let us assign a letter, and I'll say that let B be the weight of one book. Let B be the weight of one book. That is the first part. We have defined a pronumeral for the unknown, which is weight. Then 2 is we write an equation for that situation. And the equation would actually reflect the situation that the weight of 6 books is 1.2 kilograms. So that then it follows that if one book weighs B kilograms, then it means that 6 books will be weighing 6B kilograms, and 6B kilograms is equivalent to 1.2 kilograms. So we have an equation, and we have an equation which can be solved in a system, can be solved by inspection or systematically. So can we proceed and solve the equation? So we shall divide this side by 6, divide that side again by 6. 6B divided by 6 is B. 1.2 divided by 6. The division will be simple. I'll illustrate the division here. That 1.2 divided by 6. 1 divided by 6 is impossible. We bring in 0 point. And then we shall now bring 1 and 2. And then 12 divided by 6 is 2. So if we work out like that, then we'll find that 1.2 divided by 6 is 0.2. Is 0.2. But then they told us that ensure that you are answering the original question. The original question is asking what is the weight of one book. So it implies that we must have the original question answered, and it is telling us the weight of the book. Therefore, this should be measured in kilograms. Having seen that B is equals to 0.2 kilograms, what does B stand for? B stands for the weight of one book. So we can simply conclude and say that the weight of one book is 0.2 kilograms or 200 grams each. So you notice that we have given our answer and maintaining the units that are required to measure the weight. From the same, you can always go back and check if your answer is correct and reasonable by substituting B with 0.2. 0.2 multiplied by 6, you'll always find it's 1.2. And the answer is reasonable. But very important, do not forget the units as you answer the original question. Purchasing 5 apples and a $2.4 mango, costs are the same as purchasing 7 apples and mandarin costs 60 cents. What is the cost of each apple? What is the cost of each apple? So, do we know the cost of one apple? We do not know. And from our first approach, we said we must define the pronumeral for the unknown. So the unknown in this particular case is what we are saying the cost of one apple. So let us assign the value for the cost of the unknown apple. So we say, let us call it a C, be the cost of what? One apple. Now, this is the cost of one apple, and it is in dollars. So, having assigned a pronumeral for the unknown, we go back to the statement and write an equation to reflect the situation. And the situation here is that when we purchase 5 apples, so that will give us 5C. Purchasing 5 apples at a $2.4 mango, so I'll add 2.4, is the same as purchasing 7 apples and a 60-cent mandarin. So if that is the case, this should be the same as 7 apples and we have it as 60 cents, that is the same as 0.6 mandarin. Now, is this equation reflecting the situation? That is what is very important. 5 apples and a 2.4 mango costs, that is what we have on the left-hand side, should be the same as purchasing 7 apples and a 0.6 dollar mandarin. That is what we have on our right-hand side. So we have equated the two equations. If that is what is reflecting now, we move ahead and start solving either by inspection or systematically. So looking here, our interest is to find C, where C is the cost of one apple in dollars. So we can start by take this side, subtract 5C, come this side, subtract 5C. When you do that, you'll remain here with 2.4 is equal to 7c minus 5c will give us 2c plus 0.6. Then we subtract 0.6 on the right, subtract 0.6 on the left. We shall remain on the right with 2c, that is 2c plus 0.6 minus 0.6, and on the right 2.4 minus 0.6, you remain with 1.8. I've swapped the left-hand side and the right-hand side, so I have 2c is equal to 1.8. The next thing is to solve for c, so we shall divide the left-hand side, we shall divide by 2 to get c, and right-hand side we divide by 2, and when you divide by 2, 1 into 2 is 0, 18 into 2 gives us 9. So you find that c is equals to 0.9. But what was this c? C was the cost of one apple in dollars. So we need to be specific. And then go to the question, what is the cost of each apple? So it's clearly telling us to find C. So then we can agree and say that the cost of one apple is $0.9. If it is in dollars, write dollars. If it is in cents, you can still convert it. Cents. $0.9 is the same as 90 cents. So you should be able to know when to write the values that we require here. It's not anything. We are not just looking for any C. We are looking strictly for the cost, which is in any cents or in dollars. So if we have answered the original question, which was asking us to find the cost of each apple, then it means that we have observed the rule that this is a current situation and the units have also been taken care of. You find sometimes somebody just says C is equals to 0.9 and leaves there as an answer. Is it correct? If you just say C is 0.9 and you can even go ahead and say that one apple is 0.9. Is it correct? I say no. It is not correct because C should tell us the real situation. The real situation here should answer the original question, which is what is the cost of one apple. So we should say it is either 90 cents or 0.9 of a dollar. Jane and Luke have a combined age of 60. Given that Jane is twice as old as Luke, find the ages of Jane and Luke. Find the ages of Jane and Luke. For this case, what is unknown is the age of both Jane and Luke. But the total age for Jane and Luke is known. The other thing is there is a connection or the relationship between the ages of the two people here. That is the age of Jane and Luke. And the relationship here is that Jane is twice as old as Luke, which means that one person is younger. The one who is younger, we shall assign the pronumeral for the one who is younger. And who is younger in this situation? So you'll find that Luke is younger. So let us assign the unknown Luke a value. So let L be Luke's age. Let L be Luke's age. If L is Luke's age, then what is the age of Jane? Jane is twice as old as Luke. So Jane will be 2L. We've been told that the ages of the two combined, the age of Jane and Luke combined, is 60. Therefore, we take the age of Luke plus the age of Jane should give us 60. Should give us 60. By this equation, we have represented the situation of the relationship of the ages of both Jane and Luke. So we have this. From this, we move ahead and we solve. Now, you notice that this is a situation where we have like terms. So we shall be required to collect like terms accordingly and then move ahead and solve. When you look at L plus 2L is equals to 60, the like term here is L. So L plus 2L will give us 3L is equals to 60. We solve for L by dividing this side by 3. We remain with L. And when you divide 60 by 3, you'll find that you remain here with 20. Now, L is equals to 20. What is L? L is Luke's age. So which means we need to answer and show the real situation here. And the real situation here, we should say that Luke's age is 20 years. Specify 20 years. If you don't say 20 years and leave it just 20 what? We should be specific. You should specify the units that are going to be used. And then for Jane's age, who was twice as old as Luke, it is 2L, which will give us 2 times 20, which is 40 years. 40 years. Does this answer the original question? Find the ages of Jane and Luke. What is the age of Jane? And you'll say 20 years. What is the age of Luke? What is the age of Jane? Jane is 2L. So it is 2 times 20, which is 40 years. What is the age of Luke? Luke was the youngest, which was given the value L, and the L is 20, so Luke's age is 20 years. These two answers reflect the answers to the original question. So you realize that given any situation, we can come up with equations, and we use this equation to actually get the values of the real life situation that we are looking for. Sometimes it's not only in a statement or a phrase. We can also have a diagram. Still, that one reflects the real application of equations. So let us look at application of equations when we have diagrams. In this diagram, we are asked to find the values of x and find the values of y. We need to find the values of both x and y. And the diagram that we have, The angles are given as x, 100, 2x, x, and y. Why I call this an application is because you need to have the knowledge of what we call quadrilateral. A quadrilateral is any four-sided figure, like a rectangle, a trapezium, we have a square. Those are called quadrilateral. What is the relationship of quadrilateral angles? What is the relationship when you look at the angles that make up a quadrilateral? So you find we need to have that prior knowledge. And the knowledge there will always tell us that in a quadrilateral figure, we say that the sum of the interior angles is equals to 360. We need to recall that sum of interior angles of quadrilateral is 360. For this case, it means that when we add the interior angle, this y is exterior. When we add the interior angle of this four-sided figure, should give us 360. Therefore, we shall say x plus 100 plus 2x plus x should give us 360 degrees. X plus 100 plus 2x plus x is equals to 360. Again, on the left-hand side, we have like terms. If we have like terms, collect them together. So this will be the same if we rearrange it is x plus 2x plus x is plus 100 is equals to 360. So 4x plus 100 is equals to 360. We subtract 100 both sides. You remain with 4x is equals to 260. 4x is 260. So from this, 4x is 260 degrees. Then you'll divide here by 4 and divide here by 4. So that will remain 4x divided by 4 is x, and 260 divided by 4 will give us 65. So the value of x alone is 65 degrees. So x is 65 degrees. When you say 65 degrees, it's because in real situation, x represents an angle, and an angle is measured in degrees. We need the angle that we are calling y. For this, again, we need to create a situation that will show us the relationship between x and y. X and y fall on a same straight line, and a straight line is equivalent to 180 degrees. So let us come to a straight line and see. X plus y is 180 because these are angles that lie on a same straight line. But x is equals to 65 degrees. So this is the same as 65 plus y is equals to 180. Subtract 65, you'll remain with y is equals to 65, 180 minus 65, which gives us 115. So what is y? Y is 115, and you specify degrees. It's very, very important for us to show that we are looking for the units and not any other thing. So x is 65 degrees, y is 115 degrees. So we want to look at further application questions touching again on either degrees, measurements, or time, and so on. Has a perimeter of 26 centimeters. One, we are asked to solve an equation to find its side. And then two, hence, state the area of the square. So when we talk of a perimeter, what are we referring to? We know that a square is simply a four-sided figure with all sides equal and all angles 90 degrees. So if the perimeter here is 26, that is our perimeter. They're asking us to write or to solve an equation which we first have to come up with an equation that reflects the perimeter of this square. So we have the length. If all the sides are the same, then it means this L is the same as this L, and the opposite sides are also equal. But they're asking us to come up with an expression, and then we solve, which reflects the perimeter of this square. So if we say, let L be side of the square. If L is the length of side of the square, then it will mean that perimeter P is equals to 4L. The perimeter P is equals to 4L. And what is 4L? 4L is equivalent to 26. So we shall say 4L is equals to 26. We divide here by 4, divide this one by 4. You find that L is equals to 6.5. L is equals to 6.5. You can also work out that using your calculator and confirm if it is correct. So let us move to the second question. Let us move to the second question. Hence, state the area of this square. Remember, we have found that the side of square is 6.5. So what is its area? Area, I'll assign it to be our A, to be our area, is equals to length times length, which will just be length squared, which is the same as 6.5 multiplied by 6.5. If you multiply this, you can use a calculator to multiply, or you can use long method to multiply. Put in mind, when multiplying numbers, the number of decimal places are simply added together. So can you multiply that and see what you get and compare with what we have? So when you work out that, you'll find it is 42.25, and we need to specify we are looking for the area should be in square centimeters. In square centimeters. So we have answered the original question because we have given it and we have given even the units. For the first part, we were able to find the length of the side in centimeters. So it's very necessary that while working out application of equations in a real life situation, the units are very, very important. Now, that is it about the application on on equations. Now, I want us to look at another way of representing equations, but this time round, I want us to look at what we call the inequalities. I want us to look at inequalities. In most cases, we've been looking at the linear equations. We've moved ahead. We've seen the quadratic equations. We've seen the application of these equations given that we have a situation. We've been able to solve the situation and make sure we state the units of the unknowns correctly. Now, we want to look at what we call the inequalities. An inequality is just like an equation, but instead of actually indicating that two expressions are equal, we now bring in other signs like the greater than or less than signs so that we can relate the relationship between the two equations. They are actually written as equations, but we don't use the equal sign, but we use the inequality signs. Inequality signs, as we saw in our previous year, are those signs that are maybe like this. So I want you to discuss what does each of these signs represent. So in your discussion, you should have come up with the following, that this sign here represents greater than. This one is said to be greater than or equal. And last sign is said to be less than or equal. So when you represent an expression with these signs, then we come up and say these are inequalities. They are inequalities. A good example, we can say that x plus y is less than 5. X plus y is less than 5. And you'll notice this. From what you understand, from one simple inequality, we can come up with so many other inequalities. For example, here, if x added to y is less than 5, then definitely x is less than 5 and y is also less than 5. So from one simple inequality, you can come up with other inequalities to reflect the same information. These inequalities can be shown on a number line. Now when you say a number line, earlier on I was just trying to show that on a number line we have numbers on the left-hand side which are negative, on the right-hand side which are positive. Those numbers less than 0 are on the left and greater than 0 are on the right. But when you have an inequality comparing the numbers, we can also show them with the number line by saying those ones which will fall on the left of another one are less than, and those which will fall on the right-hand side of the other one are greater than. Let's see a situation like that. This is a simple number line. So if we choose to compare, 1 here and 3 here, common sense has it that 1 is less than 3. What side of the hand is 1 when you compare to 3? 1 is on the left side of 3. And I say if a number falls on the left-hand side of the other one, it is definitely less than that number. So 1 is less than 3. Similarly, 2 minus 2 and minus 1, minus 2 is further on the left than minus 1. Therefore, we can say that when we compare this one, we can say minus 2 is less than minus 1. This one is minus, we have here 1 is less than 3. So number line can be used to show inequalities at any given time when we are comparing that which one is greater than and which one is less than. So let us note the following when you are dealing with inequalities. First, we are agreeing that an inequality is a statement. It is a statement of the form left-hand side is greater than right-hand side. And when you talk like that, how do you represent that? A good example would be, if we have on the left 5 and on the right we have 2, then we can say what is on the left, that is 5, is greater than what is on the right, which is 2. That is a statement, that is an inequality. We can say left-hand side is greater than or equal to right-hand side. For example, we can simply say that this 7, if I take 7, you can say that 7 is greater than or equal to what? To 7. That is true. We can say 10 is greater than or equal to 7. This one may either be true or not because we have given the value of x as 10. And as we shall see later on, you'll see where if we use equal sign, 10 will not be equal to 7. However, 10 is greater than 7. So the statement still remains true. We can also have it that the left-hand side is less than the right-hand side. And such statement would be like 2 is less than 10. Left-hand side is less than the right-hand side. And finally, we can have it like left-hand side is less than or equal to right-hand side. And a good example there, we can say 5 is less than or equal to 5, which is true. Or we can also say 2 is less than or equal to 5, which is true, exception given to the case where we shall be equating. So those are statements. We also have what we call equivalent inequalities. Inequalities can be reversed. Inequalities can be reversed. What are we trying to say here when we say inequalities can be reversed? If we have a statement like 3 is less than x, this is true because if 3 is less than x, it will be true for a statement to also, for an inequality to also read x is greater than 3. We have reversed this, but the sign has also changed. If I may ask, which one is greater here between 3 and x following this statement? You'll say x is the largest. So 3 is less than x, and x is greater than 3. These are equivalent inequalities. Equivalent inequalities. Now, inequalities can also be represented on the number line, as we have seen earlier on. Inequalities can be represented on a number line. What do we mean by this? I want us to consider this inequality. X is greater than or equal to 5. And we want to represent this on a number line because we are saying inequality can be represented on a number line. So given a number line, that is our number line, and we want to show that x is greater than or equal to 5. So we shall go where we have 5. 5 is here. And then the direction it takes is this direction. So that statement tells us that x is equals to or greater than 5. And you come and write there, x is greater than or equal to 5. Now, there is something about the shaded part, or what I'll call closed circle. When the circle is closed, it means that point is included. But when it is not closed, let us see about this. I'll use the same to represent the information. Y is less than 4. Y is less than 4. To represent this information, we shall go the point where we have 4, we shall circle, not closed circle, but just a circle, and the direction it takes, it's less than, so that is the direction, and you say y is less than 4. So I'm saying this, when we have a closed circle, the value there is included. When we have an open circle, then it means that value is not included. For this case, 4 is not included. Only those values which y is less than 4 are the ones which are making this statement true. So here, 4 is excluded. But for a closed circle, 5 there is included. We can also represent a range. A range can be represented on a number line by clearly showing the open or the closed endpoints. We had, for example, 2 is less than or equal to x, which is less than 5. That one is showing a range. It's showing a range. And you notice that from here, if we were to break it, we can break it several times, because this one simply means here we have the first, and if we reverse this statement, it is what? 2 is less than or equal to x, which is the same as saying x is greater than or equal to 2, and this side is x is less than 5. So we can simply break that range and have it like that. So when we go to our number line, when you look at this number line, we want to represent the statement that we have here. The range is minus 2 is less than or equal to x, which is less than 5. Remember I told you about the open and closed circle. So 2 is less than or equal to x. This is a closed circle. Let us go to where we have 2 and we close the circle. That is a closed circle. But x is less than 5. We go to 5 and draw there an open circle. Then what happens? We join this. That is a range, and that range is telling us that 2 is less than or equal to x, which is less than 5. So we can use a number line to represent a range using the closed and open circles. So let us look at questions on this. Represent the following inequalities on a number line. A, x is greater than or equal to 4. B, x is less than 6. C, 1 is less than x, which is less than or equal to 5. This one is showing us a range. We are to use different number lines, not the same. So we shall have the number line for each. So for the first question, remember number line is endless. We want to represent the information that x is less than or equal to 4. So for this case here, look at 4. If we have equal or greater than, then the circle is supposed to be closed. So go to 4 and close the circle. Then the direction or giving us the area of x is less than 4, the arrow will point this side, and we state there clearly that x is, you're supposed to show greater than, not less than. X is less than or equal to 4. And we've said this part here is closed because the rest is less than. So we close this part here, and then the arrow here is x is less than or equal to 4. So the region covered is the region for less than. For the second part, we have a 6, and it is not equal to, so this is an open circle. So with your number line where we have a 6, it is endless. We identify where 6 is. 6 is open, so we have an open circle, and then the region to be covered is this direction, x is less than 6. So open circle means it is not included, but closed it is inclusive. Looking at the other example where we are to show the range of values here on a number line. As usual, the number line should range, the range we are looking for is between 1 and 5. So on your number line, we need to give closed values of that. Let me start with. Now we have that. If you look at this, x1 is less than x. It's not included. So 1 is an open circle. An open circle. X is less than or equal to 5. 5 is included. This is a closed circle. So that is the range we are looking for, which represents 1 is less than x less than or equal to 5. Less than or equal to 5. Inequalities can also be used to describe a real-life situation, just like what we saw in the equations. So there are situations where we need to apply inequalities in a real-life situation. So let us describe the following situations. Describe the following situation as an inequality and use x for the unknown. Describe the following situations using an inequality or as an inequality using x for the unknown. Fred is shorter than 160 centimeters. Fred is shorter than 160 centimeters. The unknown is that height of Fred, so we shall give it x. Now, they have only said shorter than, which means 160 is not inclusive. So this statement here will be x is less than 160. It will be x is less than 160. 160 is not inclusive. 2. John is at least as old as Maria, who is 10. John is at least as old as Maria, who is 10. When you talk of at least, it means he may be 10, but if not 10, he is more. So if we assign x to be the age of John, then John will either be greater than or equal to 10 because he is at least or at least as old as Maria, who is 10. If Maria is 10, John is either at least 10 or more. That's why we say x is greater than or equal to 10. And lastly, Rose's test score is between 40 and 50 inclusive. 40 and 50 inclusive. Now, Rose is supposed to score a test. She may score 40 or up to 50, and both of them inclusive, which implies that she will not score below 40. Neither will she score below 50, but she can score the 40 and she can score the 50. That's why we are saying inclusive. So for this case, we find that x, on the other side, we find that x is greater than or equal to 40, but also x is less than or equal to 50. So we need to bring this statement to be 1 and show us the range here. That means it will be, the least score is 40, which is less than or equal to x, which is less than or equal to 50. Now this one here, we have been able to show the range of the test score for Rose, which will range between 40 and 50 inclusive. 40 and 50 inclusive. Now, you notice that given an inequality, you can range. You can separate it and have two separate inequalities, or you can have two separate inequalities and bring them to reflect an inequality range or a range of inequalities. I want us to look at the following. Now, if you want to come up with an independent inequality which will still give us the same information, you find that if we say 1 is less than or equal to x, we can reverse that 1 is less than or equal to x. What is the equivalent of this? Equivalent of this is to say x is greater than or equal to 1. And also, when you look at the other side, we have x is less than x is less than or equal to 6. Now, these two inequalities here that we have, all of them represent this one information. So we should be able to come from two inequalities to form a range of inequality, or come from a range of inequality to form two different inequalities. form two different inequalities. There is a situation where we now work with what we call the boundaries, where we have maybe two inequalities taking us to a certain level, without not going beyond a certain limit. For example, x plus y is less than or equals to 30. From this is working with what we call within the boundaries. So the maximum x and y can go is just not anything more than 30. So that is what we call working with the boundaries. So in such case, we can get some statement questions. We can always find out what are we trying to say here. If x plus y is 30, will it be true if somebody gives you a statement and say x is less than 30? Is it true? X is greater than 30. Is it true? X, y is equals to 30. So let us see which of this statement is true and which one is false. If x plus y is equals to or less than 30, then x must be less than 30 at least. So this statement is true. But for this one, can x be greater than 30 given that if we add the two, it will give us equal or less than 30? This statement here is false. And when you say y is equals to 30, it's possible if x was 0, then y would be equal to 30. So this statement, we can say it is true. So when we work within the boundaries, we can be able to cite other areas where we are able to separate and find when are the statements true and when are the statements false. So having said this about the inequalities, by this time now, you should be able to relate inequalities in our real life situation. You should be able to represent inequalities on a number line and show the which ones are greater than, which ones are less than. You should also be able to represent a range of inequalities on a number line. Having said this, we come to the end of our lesson on inequalities. Thank you.